Welcome back again to Advanced Functions, MHF4U1. This is Trigonometric Functions chapter. In this lesson number 6, we are going to model and solve problems that involve trigonometric functions and using the radian measurements. So let's do a quick recap of what we learned so far. So we understand that y is equal to a sine b x minus c plus d. So sine could be represented with either sine or cosine or tangent. Okay. Now in the textbook, you may have seen this equation. Y is equal to a sine k x minus d plus c. Okay, so for now, I will try to be consistent by using this, but different letters or acronyms could be represented using same idea. So recall that cosine could look exactly the same as a sine graph, but except that sine x plus pi over 2. So if I were to shift the sine graph by pi over 2 to the left, then I'm going to get a cosine graph. Okay. Keep in mind, I could also get and negative sine x is equal to sine x plus or minus pi. So the reflected of the sine graph could be represented by either shifting to the left pi or the right pi. Now the axis of the function. So to find the equation of the axis, the formula looks like this. Y is equal to maximum plus the minimum divided by 2. So this is, in this case, y is equal to d value over here. Amplitude. So amplitude, the formula is amplitude A is equal to maximum minus the minimum divided by 2. Now keep in mind, amplitude is always going to be a positive number because it represents the distance from equation of axis to the maximum or equation of axis to the minimum. To find the period is equal to 2 pi over b in this case. So whatever the b is, that's what we're putting it in. Now, where the number of cycle is 2 pi radian, okay? And then if you're looking for the b value to put it in the equation, you can interchange it, where b is equal to 2 pi over period. Okay? So this is the case for sine or cosine. But keep in mind, if you're using it for tangent or possibly cotangent, then the period is going to be pi over b. Okay. So first question, so find the equation of y is equal to sine graph of a trigonometric function given below. So in this case, the first step is to identify the equation of axis. So to find the equation of axis, we're going to find the maximum point, which is 8, and the minimum, which is 2. We're going to add them. 8 plus 2 divided by 2, which is 5. It makes sense. So as you can see, my equation right in the middle ground is at 5. Now let's find the amplitude. So amplitude is the number of spaces from the equation of axis. So it looks like from 5, I'm moving up 1, 2, 3 to the maximum. And same thing, I'm moving down 1, 2, 3. 3 steps to the bottom to get minimum. Well, another way you could do it is maximum subtract the minimum divided by 2, which is 3. Now we need to find the period. So it looks like the period, let's say, assuming that it's a cosine graph. So cosine graph starts from the highest and comes back at the highest. Okay. So negative 3 or 5 pi over 4. Or on the other hand, you could do sine. It's totally fine. So it looks like if I were to do a sine graph, let's say upside down, I could start from here and then come back over here. Okay, so let's do a sine graph. So it looks like my endpoint is at 7 pi over 4, and my starting point is negative pi over 4. So to find the period is, let's find the difference. So 7 pi over 4, and then minus negative pi over 4. So negative negative becomes positive, so it becomes 8 pi over 4, which is 2 pi. So the period is 2 pi, but in order to put it in the equation, in this case, we gotta put it back into the b equation. So b is equal to 2 pi over period, which is 2 pi over 2 pi. So my b value is going to be 1. Okay, so let's put everything together. So if I want to write it in sine, assuming that I'm starting from this point, and it looks like the sine is supposed to start from up and down. But right now it's starting from down and up. So that means there's a reflection through the x-axis. So y is equal to negative, because we're starting from down and then up, a, which is 3, sine. Now the b value in this case is 1, so I just write 1x. Now the phase shift, for sine, we moved left by pi over 4. So it's going to be plus pi over 4. You have to do the opposite of sine every time you put it in the bracket. And then equation of axis is 5. Now, if I decided to write it in cosine, then all you need to do is same thing. B, D, and A is going to be same. The only difference is the phase shift. In this case, I'm moving to the left by 3 pi over 4 because I'm starting from here. So for cosine, it's going to be y is equal to 3 cosine. There's no reflection because we're starting from the highest, because for cosine it's high and then low high. So 3 cosine x plus 3 pi over 4, again the opposite, and then plus 5. So that is my final equation for sine and cosine. Now there's going to be many answers depending on what your phase shift is going to be. But for sure, there are only one answer for A value, the D value, and B value. Question number 2. A cosine curve has an amplitude of 5 units, an axis at y is equal to 1, and it takes pi radians to complete one cycle. Okay. It also passes through pi 1 and find the equation. Okay, so first we have an amplitude of 5 units. So A is equal to 5. It also has an equation of axis at y equals 1. So that means if we're assuming that y is equal to a sine b x minus c. So if I'm following this lettering, A is 5, D is 1, and then it says pi radians for 1 cycle. That means the period is going to be 2 pi over b, and we know it's going to be pi over 2 pi over b. So I rearrange, b is going to be 2. Okay. Now, so we need to find the phase shift. So first, we are going to draw in 4 sections. 1, 2, 3, 4. Period is pi over 2. It looks like my equation of axis, my middle ground is at 1, and then the highest point, 5 units up, is going to be at 6. 5 units down from 1, it's going to be -4 over here. Okay. And then because it's a cosine graph, I'm starting from the highest, coming back at the highest. Right in the middle we have the lowest, so it looks like this. Okay. Now, so as you can see, it passes through pi, 1, meaning when it's at pi, it's supposed to be here, this point. So that means this point has been shifted to come this way. Do you see that? So there is a phase shift, which is pi over 4, because each square represents pi over 4. So it moved pi over 4 to the right. Therefore, if I have to put everything together, y is equal to 5 cos 2 x minus pi over 4. Make sure you put it in a factor form, and plus 1. So that is my final equation. Question number 3. Determine the equation that will model the information in the table. Okay, so it looks like we're given the x value and the y value. Now, so x is increasing linearly by 1. Now you will notice that it is cyclic because it comes back at 3, and then comes back at 3, and then 3. So it looks like we have our highest point at 5 and the lowest point at 1. So first, let's find the equation of axis, which is maximum plus minimum divided by 2. So it's 3. So y is equal to a, let's say sine bx minus c plus d. So I can conclude that d is equal to 3. Now, what about amplitude? So to find the amplitude is maximum minus the minimum divided by 2, which is 2. So a is equal to 2. Now, to find the period, it looks like my whole cycle, it goes at high, and then it comes back low, passes the minimum at 4. So this is 1 cycle, right? So if we're thinking of a sinusoidal, it comes from my original position, high to original, low to original at 4. So to find letter B, I'm going to do B is equal to 2 pi over period, which is 4. So it's going to be pi over 2. So let's do a sine function. It looks like there is no phase shift because it starts from 3, 3, and 3. So when you're doing this for we assume that in this case there's no phase shift. Okay, starting from original, y is equal to 2 sine pi over 2 x plus 3. Okay, and that will be my equation of this table of values. Okay, question number 4. A Ferris wheel has a radius of 8 meters, an axle 14 meters above the ground, and rotates once every 200 seconds. Passengers get on at the bottom of the wheel. Create an equation to model the height of a rider in meters over time. Okay, so keep in mind a Ferris wheel looks like this. So it definitely is a cyclic sinusoidal function because it comes from, it starts from low, middle ground, to the maximum, to the middle ground, and then coming back to the low point. Okay, so just by looking at it, the radius from the equation of axis to the bottom or equation of axis to the maximum, the radius is 8 meters, meaning that's the amplitude. Amplitude is 8. And the axle is 14 meters above the ground. So my equation of axis is going to be 14. Okay, and then for period, it says it rotates once every 200 seconds. So 200 seconds, that's my period. But to put it back into the equation, B is equal to 200 over P, assuming that we're doing y is equal to, let's say, sine A sine B x minus C plus D. So P in this case, so it's not 200, my apologies, it's going to be 2 pi over P, which is 200. So 2 pi over 200 is going to be pi over 100. So this is going to be my B value. Now, well, let's see. So if I have to draw this graph, so equation of axis is at 14, amplitude is 8. So if I go up by 8, it's 22. If I go down by 8, it's 6. Okay, and divided into 4 sections. So it's going to be 200. Right in the middle we have 100, 50, and 150. Now it starts, the passenger get on at the bottom of the wheel. So we're starting from at the lowest point. So that means at 0, I'm starting at 6 meters high, right? This is the ground. And it may look like the people are getting on the Ferris wheel through the stairwell. That is 6 meters high. And then obviously at the end of the rotation, you're coming back at the lowest. And at 100 seconds later, you're at the maximum height, which is 22. And then in between, it looks like that. Okay, so as you can see, this looks like it could be sine or cosine, but it might be smart way to do a cosine graph because I don't want to put any phase shift in there. So it is upside down. So y is equal to negative 8 cosine graph, cos, and then pi over 100 x plus 14. And that will represent the equation of this Ferris wheel. Okay, question number 5. A weight is supported by a spring. The weight rests 50 centimeters above a tabletop. The weight is pulled down 25 centimeters and released at time t equals 0. This creates a periodic up and down motion. It takes 1.6 seconds for the weight to return to the low position each time. Determine the equation of a sinusoidal function that models the weight's height over time. Okay, let's see. So 50 centimeter above a tabletop. That means the equation of axis, assuming that it's y is equal to a sine b x minus c plus d. So it looks like I have my equation of axis at 50. So d is equal to 50 centimeter. And the weight is pulled down 25 centimeter. And it released at time 0. So that means you'll be pulling it down, which is like the radius of a circle. So amplitude in this case is 25. You pull it down 25, and then it's going to go up 25 centimeter. Period is, it takes 1.6 seconds for the whole to return to low position each time. So 1.6 seconds. But to find letter B is going to be 2 pi over 1.6. So if I have to do the calculation using your calculator, if I reduce, it's going to be 5 pi over 4. That's going to be my B. Well, let's draw it out. So equation of axis is at 50. Amplitude, my highest is going to be 25, so it's 75. And 25 lower, it's going to be 25. Let's divide it into 4 sections. It's going to be 1.6 seconds. Right in between, it's 0.8 seconds, 0.4, and 1.2. So it says 1.6 seconds for the weight to return to the low position each time. Okay, and then you will notice that at time 0, it's pulled down 25 centimeter. So at 0, it's pulled down at 25 centimeter, and obviously after one cycle, it's going to come back at 25 again. And then halfway, you have the highest point and the middle. Okay, so when I connect the dots, it will look like a cosine graph that is upside down, meaning reflection through the x-axis. So let's do a cosine instead of sine. Y is equal to negative 25 cosine 5 pi over 4 x, and then plus 50. And that will be your final equation.